If you're taking gases in chemistry, you would need to know all of these laws. So this is a quick video that goes over the laws that you are taught, being Boyle's, Charles, combined, Avogadro's, and then the ideal gas law. So a few things you must remember is that temperature must always be in Kelvin. So if you are given degrees Celsius, you just add 273.15 to get to Kelvin. If you are using a formula that deals with pressure, it doesn't really matter what the pressure is in unless it's the ideal gas law, but within the formula, the pressure must have the same units. If you are using the ideal gas law, then the pressure must be in kilopascals. Then just knowing the difference between these two conditions, so STP and SATP. So you should have these memorized depending on which chemistries you're in. So at STP, your pressure is 101.325 kilopascals. It's 0 degrees Celsius. And if we're looking at volume per mole, you hold 22.4 liters per mole. As ATP, the conditions are a little bit different, so we just want to make sure we have that memorized. So this first law that you would learn is Boyle's law. This is the law relating volume and pressure. So V1, P1 equals V2 times P2. With this law, just remembering that it is a change in volume or change in pressure. So if you list out your variables, V1 would be 4.0 liters. The original pressure is 1.1 atm. It's asking what the new volume will be, so V2, if the pressure was increased by 3.4 atm. So if you're increasing by 3.4, you want to add it to your original pressure. So then once you have all of that information, then we can go ahead and fill it into the formula. So 4.0 times your pressure, so times 1.1 atm, will equal the volume times, sorry, that's a time sign, just can't tell. And once you add those together, you'd have 4.5 atm. So now just isolate V2 by dividing both sides by 4.5, and V2 will equal 0.98 liters. So that's our first one relating volume and pressure. The next law that we're going to take a look at is Charles's law. So this is the law relating temperature and volume. So the law is V1 divided by T1 equals V2 divided by T2. And just like that reminder when we started, your temperature must be in Kelvin. So with this one, we have some information about volume in a lung at a certain temperature, and it's asking what the new volume will be if the temperature rises to 59.9 degrees. So in this question, we don't have to add anything together. It does give you T2 exactly. What we do have to do is convert our temperatures. So here, your original volume, 5.7 liters. Your original temperature was 37.3, which we have to add to 273.15, and that will give you 310.45 Kelvin. We want to know the new volume if the next temperature is 59.9 degrees Celsius. So again, we have to turn that into Kelvin, and that will equal 330.05. So now that we have that, now we can fill in our information. So V1 over T1 equals V2 over T2. So as soon as you get to this point, now it's actually pretty easy. If you remember that when you have two fractions equaling each other, you can just cross multiply and then divide. So 330.05 times 5.7 divided by 310.45. If you plug this in correctly and with two significant digits, you'll get 6.1 liters. So we're still answering with sig digs with all of these questions. The next law is the combined gas law. The combined gas law is now putting your three variables together, so temperature, volume, and pressure. So with this one, again, we just want to make sure our units are the same when we're looking at pressure. So just quickly looking at it, you have an internal pressure in kPa, you have an initial volume, and an initial temperature. It is asking you about volume again when the pressure changes, but now our pressure is in atm. So we're going to have to pick either changing atm to kPa or turn kPa to atm. It doesn't matter as long as they're the same. And then we have the second temperature. Again, we need to make sure our temperature is in Kelvin. So let's write some of these out. So we have V1 is 7.0 liters. we have P1, and I think I'll keep my pressure in kPa, is 106.4 kPa. And you have T1, which was your original temperature, plus 273.15. That gives you 295.15. And then your new volume is what we want to solve for. Your pressure, we're going to have to do a conversion and turn ATM into kilopascals. And there's 101.325 kPa in 1 ATM. So this conversion will get ATM to cancel, and it equals 65.8612, and this number keeps going. So keep that value in your calculator. Don't round too early. And then we want to add negative 15 to our temperature, our conversion of 273.15, and that's going to give you 258.15 Kelvin. So now that we have all this, now we want to go ahead and fill it into our formula. So I'm just going to erase this side over here. Will that go away? And start plugging values in. And actually, I might have to just erase all of it to have enough room. So if I want to erase all of that there, oh, it doesn't want to go away. This should be okay. So I'll have 7.0 liters times 106.4 kPa divided by 295.15 Kelvin, and that's going to equal the second volume times 65.86, and again, that number should still be in your calculator, kPa, divided by 258.15 Kelvin. So if you can get to this point, then just know how to do that math involved. So we can still cross multiply and divide. If you cross multiply, take this temperature, multiply it by all these numbers up here, so 7.0 times 106.4, and then divide by your 295.15. That will get you a number, and that's going to equal V2 times your pressure. So to get V2 alone, you're going to divide by your pressure. So if you can follow those steps, V2 will equal 9.9 liters. And if you're struggling with that and you need a little bit more help, let me know. I can do that question one more time, writing out all the math. The next one is taking a look at Avogadro's law. So this one is the law relating moles and volume. If it's not at STP or SATP, then we have to have a balanced chemical equation where your moles divided by a volume of one of your compounds will equal the moles divided by your volume of another one within that formula. So if it's not at STP or SATP, you must have a balanced chemical reaction, and then equation, and then we go from there. So this first one, we have 50 liters of helium gas, and then it's asking the mass of helium present at STP. So we want to remember that there is that connection at STP, that 1 mole contains 22.4 liters. So if we start with that 50.0 liters, you can multiply this by 22, oops, nope, I need that in the denominator, by 1 mole over 22.4 liters. It's going to catch up here. Let's see. Nope. There we go. Of course, as soon as I'm about to give up, it pops up. So let's try that one more time. So we have 22.4 liters in the bottom. So this gets liters to cancel. And now you're at moles of helium. So now we can turn the moles of helium into grams, because that's what mass is. And there's 4 grams per 1 mole. So now moles cancel and you're left with grams. So we'll plug this into our calculator. And from this first value, we want 3 sig digs to get 8.93 grams. The second part of this question has to do with a balanced chemical equation reacting with hydrogen with oxygen, and asks what would the volume of water be. So this is when we're going to use that formula. So when we're looking at this one, we need that balanced equation. So you have hydrogen gas reacting with oxygen gas, and that will produce water. Then we want to, oh, and it does say water as a gas, so that should be a G. Then we want to balance this out, so we'll have to put a 2 here to balance out oxygen and a 2 here to balance out hydrogen. Now that we have that, we can look at our moles. So we're relating hydrogen and we want to figure out water. So we're going to have N1 be about hydrogen, and so that will equal 2. V1 is going to be 2.3, right? The liters of hydrogen. And then N2 will be 2 moles of H2O. And I'm getting these values from the balanced chemical equation. And we want to figure out V2 of water. So now that we have that, we can go ahead and just put it into our little formula. Moles of hydrogen divided by volume of hydrogen equals moles of water divided by the volume of water. Cross multiply and divide, and you'll notice because the moles are the same, the volume would also be the same. So this just works out because the moles were the same. If the moles were different, the answer would be different. And then the very last law is the ideal gas law. The ideal gas law isn't seeing something change, so we're not looking at new conditions. What we are looking at is all of the variables within one equation. And notice here, this little point here, that units matter. We also have an R value of 8.314 joules per mole degrees, times moles times Kelvin. So this is also telling us that what we need to have everything in, and we'll need our P to be in kPa, our volume to be in liters, our N is moles, R we know our units, and T has to be in Kelvin. So let's go ahead and take a look at this. For the first one, we have 1 gram of baking powder producing 0.13 grams of carbon dioxide. What volume is occupied by 0.13 grams of carbon dioxide as SATP? So this SATP is giving us our conditions that we need. So we know at SATP that your pressure is 100 kPa. We want to figure out the volume. The moles we'll be able to figure out because we know how to go from grams to mole using the mole ratio. So there are 44.01 grams per 1 mole of carbon dioxide. We know the R value is that constant, 8.314, and we know that the temperature is at SATP will be 25 degrees, and you have to add that to 273.15. So this is one of those questions where that memorization of some values is going to matter, and maybe depending on what course you're taking, they'll give that information to you, but I know in our Alberta curriculum, you have to have it memorized. So now that we have all of that, we want to isolate the volume, so we're going to divide the P to the other side. So volume will equal your moles times R times T divided by V. So let's go ahead and write that in. So I didn't actually have a calculation there, so I'm just going to write out the work for this. So grams times 1 over 44.01. So that would be the N. Then I need to multiply this by the 8.314. To save room, I'm just not going to put in those units. Times the temperature to 98. I just want to make sure I have that right. 98.15. And then take all of that and divide it by 100 kPa. Then I go ahead and plug this in and answer to 2 sig digs, and I get 0.073 liters. So that was our really fast crash course with all those gas laws. I hope you have found that helpful. If you did, please subscribe, and please check out my channel, in particular the playlist for Chemistry 20, for more videos at this particular level. Thanks always for watching.